In this video, we are going to see a puzzle shared by the channel Good Place to Stop. I gave the link in the description. Please go and watch. I have pasted here the exact screenshot of that question. As you can see, we are given some information in the form of questions. The number one question is, let B be the answer to question 2, C be the answer to question 3. What is the sum of the square roots of B and C? The second question is, let A be the answer to question 1 and C be the answer to question 3. What is the sum of the sums of the digits of A and C? And the third question is, let A be the answer to question 1 and B be the answer to question 2. What is A plus B? Now, okay, let us proceed with the solution. Now, what is the answer to question 1? Not let A be the answer to question 1. So, answer to the question 1 is A. Answer to question 2 is B, because we have let B be the answer to question 2. And answer to question 3 is C, not here. C be the answer to question 3. Now, what is the question 1? What is the sum of the square roots of B and C? So, the answer to the question 1 is sum of the square root of B and C. So, therefore, A is equal to square root of B plus square root of C. And what is question 2? What is the sum of the sums of the digits of A and C? So, B is equal to D of A plus D of C, where D is the function indicating the sum of the digits. For example, D of n, for any integer n, D of n is the sum of the digits of n. So, B is equal to D of A plus D of C. And what is question 3? What is A plus B here? What is A plus B? Therefore, answer to it is A plus B. Therefore, C is equal to A plus B. So, we have this nice set of equations, 3 equations, and we have to solve these equations to get the answer, right? Okay, now let us solve. Substitute C is equal to A plus B in the first 2 equations. So, A is equal to square root of B plus square root of A plus B, and B is equal to D of A plus D of C. C is A plus B, so D of A plus B. Now consider this first equation. A is equal to square root of B plus square root of A plus B. Squaring on both sides, we get A square is equal to, using the A plus B whole square formula, we get square root of B whole square is B plus 2 root B into root A plus B, square root of A plus B whole square, which is A plus B. So this gives A plus 2B plus 2 square root of B into square root of A plus B. Therefore, A square minus A minus 2B is equal to 2 square root of B into A plus B, square root of A plus B. Squaring again on both sides, we get this. So, keeping A square minus A as one entity, again using the formula A minus B whole square, we get A square minus A whole square minus 2 into A square minus A into 2B plus 4B square is equal to 4B into A plus B. 4B into A plus B is 4AB plus 4B square. So 4B square cancel out. So we have A square minus A whole square, expanding this, minus 4A square B plus 4AB is equal to 4AB. 4AB cancel out. So we have A square minus A whole square is equal to 4A square B. Now this gives, taking A outside again, so A square into A minus 1 whole square is equal to 4A square B. So this means either A is equal to 0 or A minus 1 whole square is equal to 4B. Because see, when A is equal to 0, this is trivially true. When A is not equal to 0, we can cancel A square on both sides, which gives A minus 1 whole square is equal to 4B. This means B is equal to A minus 1 whole square by 4, which we can write as A minus 1 by 2 whole square. Therefore, A is equal to 0 or B is equal to A minus 1 by 2 whole square, right? Okay, now what if A is equal to 0? Consider this case. When A is equal to 0, remember we have the first equation as A is equal to square root of B plus square root of C. So A is equal to square root of B plus square root of C. When A is equal to 0, this is equal to 0. Square root of B plus square root of C is equal to 0. Since both these are positive, this is possible only when B and C are 0. Therefore, one solution is A is equal to B is equal to C is equal to 0. And note this also satisfies the second equation, right? Because B is 0, D of 0 is 0. So, this obviously satisfies the second equation. So, we have this trivial equation A is equal to B is equal to C is equal to 0. This is one solution, right? Let us mark this in different color to indicate that this is the solution. Now, note we have also got another result. B is equal to A minus 1 by 2 whole square, right? Let us write this here. Now, what is C? Remember, C is equal to A plus B, right? That equation here. C is equal to A plus B. So, we have a plus b is a minus 1 by 2 whole square. So this is 4a plus a square minus 2a plus 1 by 4. 4a minus 2a is plus 2a. So a square plus 2a plus 1 is a plus 1 whole square by 4. So this is a plus 1 by 2 whole square. Therefore, c is equal to a plus 1 by 2 whole square. Right? Okay. This is what the first and third equation leads to. Now consider the second equation. What the second equation says is this: b is equal to d of a plus b of c. Right? So b is equal to d of a plus d of c, and since c is equal to a plus b, we also have b is equal to d of a plus d of a plus b. Right? Okay. Now let us consider this equation. In this point, I want to note one thing. That is, note d of a is the sum of the digits of a, and I want to note this observation. For example, consider this 1, 2, 3 mod 9, 123 mod 9. This is 1 into 10 square plus 2 into 10 plus 3 mod 9. Right? Right? Okay. 10 mod 9 is 1, right? So we have 1 plus 2 plus 3 mod 9. This is because 10 mod 9 is equal to 1. So we have this. So what this means is 1, 2, 3 mod 9 is the d of 1, 2, 3 mod 9 is equal to d of 1, 2, 3 mod 9. That is sum of its digits mod 9. In general, n mod 9 is equal to d of n mod 9. That is, n mod 9 is equal to d of n mod 9. In other words, d of n mod 9 is equal to n mod 9. This is one observation I want to make. Okay. Now consider this equation: d is equal to d of a plus d of a plus b. So taking modulo 9 on both sides, we have d of a plus d of a plus b mod 9. Applying the result that we have got now, that we have observed now. So d of a is same as a mod 9. So this is a, and similarly this is a plus b. So we have b is congruent to 2a plus b mod 9. So 2a is equal to 0 mod 9. Therefore a is equal to 0 mod 9. This means a is the multiple of 9. Right? So a should be the multiple of 9. This is one important result. A is the multiple of 9. Right? This is one important clue that we have. Right? Great. Now remember that b is equal to a minus 1 by 2 whole square. This one. And we need b to be the integer. That means a minus 1 should be even. That means a should be odd. Right? So a should be odd, and a is the multiple of 9. Therefore, a is the odd multiple of 9. This is one thing I want to know. So a is the odd number and it is the multiple of 9. Therefore, a is the odd multiple of 9. This is one thing. That means a can be anything: 9, 27, 9 3s are 9 4s are 36, 9 5s are 45, and so on. A can be any of these, right? So a is the odd multiple of 9, and we have b is equal to a minus 1 by 2 whole square, and c is equal to a plus 1 by 2 whole square. Now we are going to apply the c value and d value in this equation. So we got b is equal to d of a plus d of c, and b is equal to a minus 1 by 2 whole square is equal to d of a plus c is a plus 1 by 2 whole square. Right? We have substituted the b value and c value in the second equation, that is b is equal to d of a plus d of c. We have this. So this is what we got finally. Right? This equation has only one variable a, that is a minus 1 by 2 whole square is equal to d of a plus d of a plus 1 by 2 whole square, and a is the odd multiple of 9. A can be 9, 27, 45, anything. Right? Now consider this equation. This is the equation that we have now. Consider this, and let n of a be the number of digits in a. So remember, d of a is sum of the digits of a, and now we define another function n of a such that n of a is the number of digits of a, right? And also one important thing is d of a, which is the sum of the digits of a, should be less than or equal to 9 into n of a, because a has n of a number of digits and each digit has the maximum possible value of 9. So d of a should be less than or equal to 9 into n of a. Okay, so this equation becomes an inequality. Let me copy this here. So this is the equation that we have, and here let me copy this. This becomes the inequality like this: 9 into n of a plus 9 into n of a plus 1 by 2 whole square. Therefore, a minus 1 by 2 whole square is less than or equal to 9 into n of a plus 9 into n of a plus 1 by 2 whole square. Now remember, n of a is the number of digits in a, number of digits of a. And also it is easy to see that number of digits in any number a is equal to log base 10 a, floor of log base 10 a plus 1. This is easy to see, right? Because we need the largest power in the largest power of m in the decimal expansion of a, right? So we need something like this, some m such that a should be less than 10 power m plus 1, and it should be greater than or equal to 10 power m, and the number of digits in a is simply m plus 1. We need this value, and we can take logarithm on both sides, and taking floor value we get this result. All I want to note is this, that n of a is the logarithmic function, right? We don't even need the exact function here. All I want to say is this, the right hand side function, this function grows very slowly, right? This is related to logarithmic function. This is growing very slowly at very slow rate. But on the left hand side we have a minus 1 by 2 whole square, which is quadratic. It is expanding more rapidly and at higher rate when comparing with the right hand side function, right? This is one thing I want to note here, right? Now remember, a can be any odd multiple of 9, so a can be 9, 27 and so on, right? When it is 9, suppose a is equal to 9, let us see the fate of this inequality. We have 9 minus 1 by 2 whole square, so 8 by 2 whole square. So on the left hand side we have 4. On the right hand side, n of a is the single digit number, so a is equal to, n of a is equal to 1, so plus 9 into n of a plus 1 is 9 plus 1 10, 10 by 2 5, 5 square 25, n of 25 is 2, therefore this is 2 into 9, 18, 18 plus 9 27. So this inequality holds. This inequality holds for the case when a is equal to 9. So what happens when a is equal to 27? So this becomes 27 minus, the left hand side becomes a minus 1 by 2 whole square is equal to 27 minus 1 is 26. So 26 by 2 13, this is 13 square, so 169. But on the right hand side we have 9 into n of a, so n of 27, 27 has 2 digits, so 2 plus 9 into n of a plus 1 by 2 whole square, 9 into n of 14 square. So this is 18 plus what is 14 square? 14 into 14, 4 4s are 16, 56, 196. So we have 196 here. So n of 196. Obviously this quantity is less than 169, right? So we have 18 plus 16, so now 1 plus 9 plus 6, 16, 18 plus 16. So this is obviously less than 169. So for a is equal to 27 itself, this inequality fails, right? Therefore, since they are these both functions grow at a different rate, and also the left side function grows very rapidly at higher rate comparing with the logarithmic function on the right, and this inequality fails at a is equal to 27 itself. So for any larger value of n, this inequality cannot hold, right? So therefore, the only possible value for a is 9, and this we need to check whether this satisfies our three initial equations. Remember, b is equal to a minus 1 by 2 whole square, and c is equal to a plus 1 by 2 whole square, right? So this means a is 9, so 9 minus 1 is 8, 8 by 2 4, 4 square, so this is b is equal to 16, and c is 9 plus 1 10, 10 by 2 5, 5 square 25, c is equal to 25. And remember our equations, a is equal to square root of b plus square root of c, and 2, b is equal to d of a plus d of c, and 3, c is equal to a plus b. And based on the first and third equation, we have got b is equal to a minus 1 by 2 whole square, and c is equal to a plus 1 by 2 whole square. So they obviously satisfy these two equations. So only thing we need to check is the second equation, and for the second equation, the left hand side is 16, b is equal to 16. On the right hand side we have d of a plus d of c. D of a is d of 9, which is 9. D of c is d of 25, 2 plus 5 7, so 16. So this the second equation also holds. Therefore, this is indeed the solution. A is equal to 9, b is equal to 16, and c is equal to 25 is the solution. And this is the wonder solution. There are no other solution possible. Therefore, in the middle we have seen that this is one solution. A is equal to, b is equal to, c is equal to 0. And now we have got another solution. Therefore, this has only two solutions. A is equal to, b is equal to, c is equal to 0. And a is equal to 9, b is equal to 16, and c is equal to 25. So these are the only two solutions for this question. Once again, thanks. Good place to stop for this wonderful problem, and thanks for watching. Thank you.